Hey class, Absolute 5 here. So today we're going to be finishing off with the opposite from the vertical asymptote to the horizontal asymptote. So real quick, it's basically like a border for the function, it's just horizontal. Like it's a wall for the function. So what's the definition for a horizontal asymptote? Def. Let's see what it says. The line y equals L is called a horizontal asymptote of the curve. So for y equals f of x, if either the limit as x approaches infinity of f of x, whatever our function is equal to whatever the limit is, or the limit as x approaches negative infinity is still, for our function, whatever our function is equal to the same value. So this is saying how it doesn't matter as long as I get one value on the limit as x goes to infinity for my function, if I get whatever the value is here, or if I get the negative version of it from negative infinity for my function, I get the same thing, then you have a horizontal asymptote. So what's a good example of this? A great example that we could use for this, for a horizontal asymptote, is the x-axis. But the example we'll use is this. Find the limit as x approaches infinity of 1 over x, and the limit as x approaches negative infinity of 1 over x as well. So first off, let's start off by taking some values first. So let's say I say x is equal to 100, right? 1 over 100 is the same as 0.01. And if I do 10,000, I get 1 over 10,000. It becomes 0.0001. And just for one more, just so you guys can see the pattern. 1 over, let's see, if x equals 10,000 and x equals 1,000,000, I get 0.000001. So what's the point of me selecting these values? Now, the pattern is this. As x gets extremely large, our specific function, 1 over x, gets so tiny, like it gets so small, like it looks like it's going to 0, because you see how tiny this function is becoming, this numbers are becoming. So it makes sense that as x gets extremely large, our function goes to 0. So if we actually took the limit as x goes to infinity of 1 over x, it would be 0, because based on the pattern that we're seeing here, it's going to 0. Now, the same is true if I took the opposite. If I take the limit as x goes to negative infinity, I would get even smaller than these numbers, because in the end, well, technically I would still get 0, but I would have negative 0.00001, and and these pretty much I would have the exact same values of each one of these, but they would be negative. So this would be on the left side, and this would be on the right side of the function. I'm going to graph it for you guys right now. So it's kind of fascinating to see how we're trying to understand the concept of infinity. You would think infinity is something that you can't really use at your disposal, but you can actually do some things with infinity. Not too much, but you can do some things with it. Okay, so let's say this is the x-axis, this is the y-axis. Okay, so ideally here is on the right side, it's going to be our limit as x approaches infinity for 1 over x, because as x gets infinitely large, the numbers keep getting smaller and smaller and smaller and smaller and smaller and smaller, and eventually it's going to touch 0. But the point is, you see that how it swerves off to the right. That means x, the x-axis, is our horizontal asymptote. So meaning this function can't hit that part. And if I took right over here, the limit as x approaches negative infinity, as I choose values from y, well, the outputs, they keep going up and up and up and up, but they're negative, but then it starts swerving to the left, and that you can't really touch 0, but it swerves off to negative infinity. So, I forgot to put the rest of it. The limit as x approaches negative infinity of 1 over x, that's this function here. You see how they're inverses of each other, but they know that they cannot really risk touching the 0, because thus we have undefined. So that's the horizontal asymptote. So I hope the vertical and horizontal asymptotes make sense now. And just remember, just think of them as barriers that the function cannot pass through no matter what. So this has been Absolute 5, and I want you guys to know that I want you to subscribe, like, share to this channel, and also to, if you like my content or you have any suggestions, please leave a comment below and hit that bell button right next to the subscribe button, so this way you can get more mathematical content from me. So thank you for watching, and never forget that math is infinite, and because there are infinitely many possibilities, okay? So have an absolutely lovely day.